This is Jenny Kunkel, and in this video we're going to talk about locking. And within SQL Server we have 10 levels of lockable resources, and this is going to include the database, the allocation unit, the metadata, the file, the table, the heap, or B tree, the extent, the page, the key, and the row. Common server lock modes are going to be shared with the schema stability, the intent, shared, the shared, and the update. And then we have exclusive locks that are going to include the share with intent exclusive, exclusive, bulk update, and schema modifications. And essentially, we can take a look at a transaction that's going to potentially result in a deadlock. So we have transaction A. It's essentially going to have a repeatable read for its isolation level, and we're declaring money. Once we start our transaction, we're going to go out and retrieve the invoice line items for what the total is based off of invoice 101. We're going to wait for 5 seconds, and then we're going to update that value and commit the transaction. Then if we look at the second transaction, this is going to be transaction B. Notice that transaction B is essentially the inverse of what we had before. In our prior slide, if we go back, we can see that we're updating the invoices based off of the total that we get from the invoice line items. In this case, we are getting the invoice total from the invoices to update the invoice line items. And this is going to result in a deadlock. Now, things that we can do to try to prevent deadlocks is not to allow transactions to remain open for very long. Essentially, just do what we need to do from the update perspective within the transaction and get it committed or rolled back. We can also use a lower transaction isolation level. And when we talk about the lowest possible transaction isolation level, we are going to discuss a little bit more about that when we get into pessimistic versus optimistic locking. That's not something that the textbook actually talks about, but when you're creating applications, you need to know about optimistic versus pessimistic locking. And then also, if we're going to make changes, essentially to a large number of records, and you need nearly exclusive access in a lot of cases, those would be things that we could do off shift. If we're working in a factory, maybe third shift when things are not necessarily as active, we don't have as many users accessing the system, then that would be a good time to do it. Or if you have a shutdown period, that might be a good time to do it when people aren't on the system actively working to cause a lot of conflict that might result. You can also consider locking when coding your transactions as well. Now, we have an example here where if we're transferring money from savings to checking, and then we have from checking to savings, again, we have that inverse situation. And if we can code them predictably, like in this last case where we're trying to do the reverse order to prevent the deadlocks, we can also accomplish some of those types of things. The next thing that we want to talk about is not in the slide deck, but it is something that is important, and that is the difference between optimistic locking and pessimistic locking. And so if we think about optimistic locking, we should assume that we're not going to have very many conflicts. And we only really want to get a hold and lock the records when we need to commit the updates to the database themselves. So when we're committing the change, that's the only time that we really want to lock it. Now, one of the advantages of doing this is that there is less overhead on the locks, but then you have other issues because you're running at a lower isolation level. We saw how we can have dirty reads and some of those other issues. One of the things that we need to do, though, with optimistic locking is we need to make sure that nobody has grabbed the record after we read it, and now we're ready to make our updates to the database and apply those changes. We need to make sure that nobody has snuck in and actually made a change to the record that we plan on updating so that we don't lose any data and we can have consistency with our data. And one of the ways to do that is, if we were thinking about from a SQL Server perspective, maybe we go out and we add a couple different columns to each table that we are concerned about doing this optimistic locking for, and we essentially are going to have a timestamp and a version, because obviously we could potentially add something at the same time, or we could update something at the same time because we have concurrent updates. Therefore, we might have to have a version for a particular timestamp to make sure that we have uniqueness. Then, of course, anytime that we're updating any of the information, we have to update our version and our timestamp so that we can make sure that we see those updated changes. Or we need to come up with some type of hash code that we can generate based off of a row that we select. And then if we go back to the database, be able to generate that hash code again, ensure that those values are the same, and then we could proceed with our updates. So a couple different ways with SQL Server. Now, Oracle for optimistic locking is a little bit more convenient. They have some built-in features, and one of those features is I can create a table with this row dependency. So if I go ahead and I try to create this table, it's going to go out and create it. The create statement looks exactly the same, except now it has this row dependencies. And what it's going to allow me to do is I can select any row and have its aura underscore row SCN value. After it's been committed, I can see that value. And anytime that I apply any update or any insert, it's going to add that aura row SCN value and update it. So if I go ahead and insert a record into that table, I can go out and I can look at my aura row SCN value, and I can get it. And I'm going to go ahead and copy it. And I'm just going to put it in a comment here. So we see that it's 408, the last 3 digits. And then I'm going to go ahead and I'm going to update it and then reselect it. And I should see that that number is actually going to change. And now it's 654. So it did change. Now, if I do not use the row dependencies on the table definition, I can still use the aura row SCN, but if I update a lot of different rows in a particular table at a given time, they're all going to have the same aura row SCN. So the real way to make sure that each row has a unique aura row SCN value for every update that's applied is to define the table with that row dependency. Now, why are we so concerned about optimistic locking? Well, in a lot of cases, we don't have much choice. I worked on one application. It was a web-based application, and we were using shared pooling. And when you use shared pooled connection resources, you don't have a maintained connection for your application because the web request is going to essentially come in. It needs a database connection, go to the database pool, get a connection. It could be any connection. It's going to do its thing, and then it's going to return the connection, and then it's going to go back and display the web page. Then the next time it comes back in, it's going to ask for a new connection. It could get the same connection. It could get a totally different connection. So there's no contiguous connection that it's maintaining, and therefore you may have sent data out to show some data on the screen. It has a certain aura row SCN at that point. It comes back into the program to be updated because a user maybe sat on that screen for 5 minutes or something, and in the meantime, somebody else came in, they queried up the record, they got their aura row SCN record value out, then they updated it. Now that record coming in has a whole different aura row SCN value, and you would have to go ahead and change that value. Now, if we're doing something where we maintain a consecutive connection to the database, we don't have a situation where we're making a web request and have no guarantee that we're using a continuous database connection, we can get by with pessimistic locking. But for web applications, you really are going to be using optimistic locking, which means that you're going to have to be doing a lot more checking to make sure that something doesn't get updated. Now, pessimistic locking, of course, is going to be a lot nicer because you can put locks on things. At any point in time, it's just going to hold that lock. It's going to be exclusive. It's only going to free it up. And then other people are going to be waiting until it gets freed up in order to actually provide that. So this is something that is a lot more reliable. However, it doesn't necessarily work for web applications. Hopefully this gives you a little bit more context of locking and some of the pros and cons.